This video is going to take a look at quadratic functions. We're going to create a 5-point graph of a quadratic function by working with it in its factored form. Okay? The 5 points that we're going to look at are the two x-intercepts, known as the roots or zeros, the y-intercept, the vertex, and the point that you can graph by reflecting the y-intercept over the axis of symmetry. So we're going to find the axis of symmetry as well. Okay, this will refer to some of the notes from class as well. So let's get going and get into the meat of this by looking at this function y equals x squared minus 2x minus 3. And we'll look at finding the x-intercepts. When we say x-intercept, immediately we have to think y equals 0. So that'll allow us to write 0 equals x squared minus 2x minus 3. And our first look at trying to solve this, we're going to move this into factored form. So I'm going to take a look at this in factored form and think, what are the factors of negative 3 that add up to negative 2? And they're, in fact, going to be 1 and negative 3. So I factor this into x minus 3, x plus 1. And from there, I'm going to see that I'll apply the zero product property, which you'll see in your notes, and solve for x in both of these. And I'll get 3 and negative 1. And I'll just plop those down on my graph. They're the x-intercepts. They go on the x-axis. So we've got 3 and negative 1. Now I'm going to find the axis of symmetry. Okay? The axis of symmetry, when you're dealing with this form, you can refer to your notes again, is gotten by doing x equals r1 plus r2 divided by 2, which says that I'm averaging the root values. Okay? This is r1, the first root. This is r2, the second root that I found in the previous step. Okay? Again, the axis of symmetry is going to be a vertical line, so it makes sense it's of the form x equals some number, so that its graph is a vertical line. So I'm going to get 3 plus negative 1 over 2 equals 2 over 2 equals 1. Excuse me. So I'm just going to graph x equals 1. I'll graph it with a dotted line. I'll even be so good as to label it x equals 1. Okay. Continuing on, I'm going to find the vertex now. The vertex is pretty simple. The vertex is a point, and it's going to be of the form 1 comma f at negative 1. And how do I know this? Well, I know that the vertex is somewhere on the axis of symmetry line. So I know its x value will be 1. And I can find its y value by just plugging in 1 to the original equation. I'm just using the function notation here, which says f at 1. We have that y is equal to f at x, so I'll just do y equals 1 squared minus 2 times 1 minus 3. That's going to give me 1 minus 2 minus 3, which is equal to negative 4. Thinking of this as a point, I'm going to get 1 comma negative 4, and that is going to give me the vertex. Okay? Now, for the y-intercept, we want a knee-jerk reaction when we say y-intercept, and that knee-jerk reaction is x equals 0. Similarly, when we say x-intercept, we want to say y is 0. But for y-intercept, we want to say x is 0. Well, again, if I know x is 0, I could find y by doing f at 0, which just means to plug it in. So I'm going to get y equals 0 squared minus 2 times 0 minus 3, which is going to give me negative 3. So my y-intercept is 0, negative 3, and I'll graph that. Now the last part is not really done with a formula. It's just the reflected y-intercept point. And to do that, I just examine the distance from the y-intercept to the x-axis, and I note that it's 1. So I'm going to go 1 grid in the opposite direction. In this case, that'll be to the right, and graph a mirrored point image there. In this case, it'll be 2, negative 3. So it's almost as if I'm saying 1 grid right of the axis, comma, negative 3. It's kind of a way of looking at it mentally. From here, I have 5 points. I'll just try and connect the dots in as parabolic a fashion that my freehand allows. And that is that. So, in a review, we just need to realize that the x-intercept is gotten by factoring the given expression, setting it equal to 0, and using the zero product property. This formula here is the average of the two roots, which is going to help me find the point that's right in between the roots. And if I think of it as a line, it's x equals that number. To find the vertex, well, again, I know it's on the axis of symmetry, so I know the x value is 1. And you can always get any y value by just plugging into the original function. It's nice to see that notation f at 1 there. Okay, the original function doesn't say f at 1 per se, but mathematicians accept that pretty readily as well. You must be plugging into the function using 1 as the x value, the domain value. Okay, the y-intercept, again, knee-jerk reaction of x equals 0 when we hear y-intercept. So to find a point, x is 0, do f at 0, which is just more plug and chug. And the reflection is just, again, looking at that distance from the y-intercept to the axis of symmetry and mirroring it over on the other side. So those 5 points help us make this quadratic function. Again, I dealt with it in factored form. You're going to need to deal with it in general form and vertex form as well. Okay? So you're going to have to be able to take any form of a quadratic and generate these 5 points that we talked about here for its graph.